everyone. Last session we discussed about how to calculate an area between two curves. This time let's downgrade to area between one line and one curve. Comparing this should be easy, right? Think about comparing because two curves and one curve and one line. But I feel it's very useful, so I have set up this session because it's made you be because we always encounter that before we learn that integral, we never know that how to calculate those kind of area, right? So I give you two examples to solve the area, okay, between the intersection of the curve and the line, okay. So first we see here, first example is here. This one even don't need to use integral. If you use integral, it's apparently a little hard because of you have to be integration for the circle. Integration for the circle is not easy. Okay, so so I will not solve this one in integration, but the second one I definitely will use. So because for this one is a kind of less special, so easy to solve. So let's see, There I want to calculate the black area here. Already solved here. This is the circle and the line intersection here, right? The good things, the intersection here exactly the number here is -3, here is 3, right? And we know that here is a circle, so the radius is 3 as well. Okay. So since we don't use integral, so we have to think about other way just based on observation. For this area, the intersection area, we just suppose this area. I just make it as area A. Okay, it's area A. A is area. There is areas. So A1, just make it as A1. Okay. A1, the area F1 equals to what? Equals to what? One-fourth the area of circle. Am I right? Anyway, this is just what I'm thinking about. This may not be the standard way. So, am I right? This is the 1/4 of the, it's like a pie, apple pie or something, whatever, a circle. And the minus here is what? Is a triangle, right? Minus triangle's area is 1/2. What? Base times height. Am I right? So this is equals to what? Area of the circle is pi r square. R is what? 3. So it's 9. Alright. Minus 1/2. Base is what? Base is 3, right? Base is 3, right? We will not say that it's a negative positive because we talk about area, okay? So base 3. Height also 3, right? Alright. So this will be 9/4 pi minus what? 9/2. So this is already final result. You can make it like more details, okay? So we already get this one. So comparing this part is quite smaller compared with the triangle as well as the 1/4 pi, right? So this is first. Second, we'll come to normal, how to calculate it, this one. This is the 9. 9 is y equals to x plus 2, and the hyperbola is y equals to x squared plus x minus 2, and I want to calculate the area here in between, right, intersection. So several things need to get. First, we need to get, since we use integral, right, we need to get the x, right? So the intersection of x. Simply and luckily, the x here is one is -2, another one is 2. Am I right? So we already writing 2 and 2. So what we need to write in here, the area of this part, just like area A, area A1. Okay, A1 is equals to what? Integral, of course, 2 minus 2. So think about that. the 9 is on top, right? So we should write in as the 9 is x plus 2, right? Then the curve is below, right? Am I right? We just calculate the curve, so it should be minus 1 x squared plus x minus 2. Am I right? And then this together is dx. Am I right? If you say why not like this way, you just think about this like every point is here is like it's like the y here minus y here minus y here, right? So this is the length, this is the y, right? Theta y, and the change theta y is here, theta y, and the change of every x theta x, right? Change of every theta x, and then it together times together is the area, right? All right, and this nice area, right? This is the concept of the what? Integration, right? This is a concept of integration. So do like this way. So what this would be like? X plus 2. So here, negative x squared. X plus 2 minus x down. 2 minus minus 2, so plus 4, right? Then dx. So this will become what? So negative 3 x cubed plus 4x. Am I right? And here 2, negative 2. Am I right? So then this will become what? This will become 2, right? So 2 is 8, right? Negative 8 over 3, then plus what? 8, right? This is one part, then minus another part, right? So negative 2. So negative 8 over 3, am I right? And then plus what? Negative 8, am I right? Am I right? And then of course raise. So this would be like what? Actually, this is will be positive. This will be positive and negative. So negative, right? This negative 3 over double, right? So this will be negative 8 minus 2 over 3, right? How about this side? 8 minus 8, so it's plus 8, so it's 16. So total area is equals to what? This can be negative 16 plus 3 times, so it's like 48, right? Over 3, am I right? So it's like what? 32 over 3. So this is the area. Okay, got it. So thank you very much to join this session, and I hope this session is useful to you and really open the way for you to calculate the area for those irregular shape, right? I feel it's kind of it's quite feeling good because if we don't know integration, we never know how to solve these things. Of course, when I prepared my example, I use those kind of the simple intersection always in a normal number, right? I'm not get a decimal. If you get decimal, you increasing your difficulty to calculation. That's not my purpose for this session. Okay, so thank you very much to join this session, and have a nice day. Bye bye.